Okay, so the first three questions, you have to describe the transformations from the parent function. And then we're going to use a table with at least 5 points. We're going to start with the transformations. I am going to give you that same like half sheet of paper that you guys could use on the first quiz on this one to help with the transformations. But that's all you will get. So we'll talk about different things we want to remember, okay? So for number 1, the vertex, you can pick it out right away. So this is in vertex form, so right away we should know the vertex is 2, 2. You look on the inside, if it's -2, remember it's a horizontal translation. So this is a horizontal shift or horizontal translation, 2 units to the right. Okay, and then it's a vertical shift 2 units up. Now these do match the vertex. Okay, so we're going to do that first for all of them, and then we're going to go to the next steps. For 2, you can simplify this if you would like to in order to find the vertex. But the negative means there's going to be a reflection over the x-axis because it's on the outside. And remember, anything that's inside is going to be a horizontal transformation. And then you have to use the reciprocal. So this would be a horizontal compression by a factor of 1/3. Remember, there are equivalent transformations, so it would also be correct to say a vertical stretch by a factor of 9. You don't have to say both. And then the factors are always positive, because if you have a negative in front of it, that's going to be a reflection. Okay, so you can have the horizontal compression, or you can have the vertical stretch, and then check your factors there. Okay, and then number 3 is very similar to number 2. Again, you're going to look at the reciprocal. So it's a horizontal stretch by a factor of 2, because that's the reciprocal of 1/2, 2/1, which is 2. Or you could say it's a vertical stretch by a factor of 1/4 if you simplified. And yeah, let's get questions on just the transformation part.
So, if we can put down vertical stretch or horizontal compression, and those are like interchangeable.
Yes, they are.
Okay.
So basically, you can use the simplified version, or you can use the original. So the original, it's inside the parentheses. Yeah. And then just make sure if you do use the simplified that you have applied the square part correctly. Sometimes people mess up on that. Okay, good. Yeah, Lizzie?
For number 2,
Yeah.
so I did the horizontal compression,
So it won't be a horizontal compression because you have to use the reciprocal. So if you said like a horizontal compression by 1/2 to fix that, you,
number 2.
oh, sorry.
And then
Oh, thank you.
A reflection across the x-axis, so then it was on the full y because I already have an expression.
No, I'm not sure what you're saying. So you're saying, so for either one, you're going to have that negative on the outside, which is the reflection over x. Okay? And then you said you had the horizontal compression, right? Okay. But was your factor not 1/3?
No, I think I just got confused between the reflection on the x and the y.
Oh, okay. If the negative was inside the parenthesis, then it would be the reflection over the y? Yes. But for both of those, if you simplified it, you are going to have the reflection over x on the outside. Okay, good. All right, other questions from you on the transformation part? Yes? Yeah? Yeah. Then there wouldn't be a reflection, correct. Yep. The negative would either be on the outside for x, or if it was on the inside, it would be over y. Okay? All right, so that was the first part, describe the transformation. Then it said to graph each function by making a table with at least 5 points, and then we're labeling on the graph. Okay, so I'm going to show you what my tables were. Remember, when you're making the table, the first thing you want to do is find the vertex. So if it's in vertex form, you can pick that out right away. Okay, if it is not in vertex form, which this one is not, you want to simplify it first, and then you do the opposite of b over 2a. Okay, so simplify, opposite of b over 2a is going to give you 0. And then to find the y, you're just going to plug this into your expression. So negative 9 times 0 squared will be 0. And then from there, you can generate your table. And remember, I also showed you on your graphing calculator how you can find your table. Do you guys want to go over that again? Which one do you guys want to use, the 2 or the 3? Or number 2 or number 3? Do you guys have a preference or not? Number 3? Perfect. Okay, so for number 3, you can decide how you want to put it in your graphing calculator. You can put it in like the first one. You don't have to use the simplified version. Okay, so I can show you how to do that as well. So we're going to go to y equals, okay, and then in parentheses, I'm going to do 1 divided by 2 squared. And then to get to the table, you do second and then the graph button. Okay, and then, oh, I must have done something wrong. I didn't put my x in because my table looked a little crazy there. I'm actually going to put this in as 0.5x. You could also do 1x divided by 2. That would be fine as well. Squared. All right, and then I'm going to go to second to get my table, second graph. And then I just can't tell you what buttons to push when you're on the quiz. So I would just practice this now to make sure that you remember it. And that way, if you have a question, I can answer it for you today. For number 3, we have 0, 0. So I would just go 2 up and 2 down from that. And you should see, once you have the vertex, you're going to be able to see the symmetry. Okay, so you have 0.251. Like if I put the 0 in the middle, you can see these are symmetric. They start repeating. So that's why you want to find the vertex first with the opposite of b over 2a. You don't even have to plug the x back in. You can use this, right? 0 and then 0. And that's fine. So one big thing you do have to remember for tomorrow is x equals the opposite of b over 2a. Okay, that's your x-coordinate of the vertex. All right, good. And then once you have your table, you're just plotting those points. So I have my number 1 here with my points. Here's number 2. Here's number 3. And just check to make sure that your graphs are opening the right way. And you can also check to make sure that your transformations match. Okay, is it shifting? Is it becoming narrower or wider? All right, any other questions on 1 through 3? 1 through 3. All right, then let's talk about vertex form here. Okay, so it says use the description to write a quadratic function in your vertex form. That just means that you don't have to simplify it. Okay, so for number 4, there are 2 possible ways that you could write this. The way that you perform the transformations matters. So you do have to do those in order. Sorry, I know that's overwhelming. Okay, so the first thing is it's reflected across the x-axis. So the negative goes on the outside of x squared. Then it's horizontally stretched by a factor of 3. So when I see horizontal, I automatically make a little note for myself that it's the reciprocal. So if it's stretched by a factor of 3, when I plug it in, it's going to be 1/3. And to do this, I'm using my rules, right? My f of 1 over b of x. Okay, and then I'm plugging that into the function, but I'm keeping everything I did in step 1. Okay? And then for step 3, my last step is translated 2 units down. Because that is on the outside, I'm going to put the -2 here. And then if some of you did simplify, because you can simplify this, it would be the negative 1 over 9 x squared minus 2. Okay, so it's on the outside there. Okay, what questions do we have on number 4? Writing the equations. So remember, the order matters that you do those, okay? All right, let's talk about the next one. We have this story problem about a ball being dropped from a tower, and they define the variables for you. So the t is the time, the h of t is the what? What's the h of t? The height, okay? So it says the height at that given time there, okay? And then, so they give you a function for the top of tower A, negative 9.8 t squared plus 400, and then from tower B, you have the negative 0.98 t squared plus 200. So you can notice the thing that changed is instead of plus 400, it was plus 200. So what happened? Yeah, it dropped. Sorry, I thought I had zoomed out, but I did not. Okay, so it's saying what transformation describes this change. So if it's a drop, that is a vertical translation, and you're going down by 200 units. Okay, so make sure you identify whether it's vertical or horizontal, and then it is a translation, so make sure that you include that. Okay, so don't just say down by 200 units, make sure you say it's a vertical translation, down. Okay, and then it says, what does this represent? So I said the height has dropped by 200 units. I don't think it told us what the units were. Okay, but you could, did some of you say like one tower was shorter by 200? Because that would be fine. Yep, same thing. Yep, so you can say tower B is shorter by 200. By 200 is fine. But then it didn't say the units. So. All right, questions for me on number 5? 5 is good. All right. Then let's talk about the axis of symmetry. So I'm going to give you just the answers before I show you all the work part. And then we can talk about our notation. So for the axis of symmetry, remember you have to have the x equals. Okay, so you have x equals 2, x equals 3/4, and then x equals negative 3. How do you find the axis of symmetry? What do you use? Good, opposite of b over 2a. Right, so I would write that somewhere. It has to be the x equals, so you will not get full credit if you just put 2, 3/4, and negative 3, and that's because the axis of symmetry is a line. Okay, and because it's a line, you have to have the x equals. Okay? All right, and then for 8, now notice that 8 is not in standard form. So 6 and 7 were in standard form. We do the opposite of b over 2a. But for 8, it's in vertex form. Okay? And that is actually even quicker because the axis of symmetry is always what coordinate of the vertex? The h value or the x coordinate? Yup. So if you can pick out the vertex, which is negative 3, 9, okay, the axis of symmetry is always going to be x equals that h value, so x equals negative 3. Okay, so when you're picking out the vertex, this number in front doesn't matter. It's always the opposite of the inside and then what you have on the outside. Yes? For number 7, I would take either one. It's fine. Yes. If it is not a nice decimal, like an even decimal, then I would prefer it as a fraction. Yes. Yes. All right, good. Yep.
For number 8, if we were to like simplify it, would we be able to get
You should still get the same answer, but if you simplified it, remember that x plus 3 squared really means x plus 3 times x plus 3 plus 9. So what you would have to do is multiply those together with FOIL. then distribute the -4, then add the 9 on. And then you could do the opposite of B over 2A. So don't do that to yourself. But you could, yes. Yes, yes, yes. All right, let's check our answers for 9 and 10, and then I'll show you the graphs. So for 9 and 10, for part A, when you're determining whether it opens upward or downward, you are going to have to explain why. And remember when we did our notes, we really focus on, we have to make sure we identify what the A value is. So for the first one, you could say downward because -1 is less than 0. That's fine. Or you can say because the A value of -1 is less than 0. Or the A value of -1 is negative. That would be fine. So we're being very explicit about that. We're saying it just like it is. And then for 10A, it's upward because A equals 2, which is positive, or upward because A equals 2. And then you can say because 2 is greater than 0. That would be fine as well. Okay, for 9, you have the axis of symmetry. Make sure it's x equals. So x equals 3 over 2 or x equals 1.5 is fine. The vertex is 3 over 2, 13 over 4. Again, those are nice decimals, so if you wrote those as decimals, that is perfectly fine. The y-intercept is 0, 1. Write that as a point. And the, the range. So the range is y such that y is less than or equal to 3.25. You do need to put that in set builder notation. And then for 10, your axis of symmetry is x equals -1. The vertex is -1, -4. Y-intercept is 0, -2. And this time it is y is greater than or equal to -4. So let's talk about why those work out, and I'll show you how I did my work with these. So, the decimal was 3.25 if you wanted to know that for this one. So to find the axis of symmetry, I'm doing the opposite of B over 2A. You could plug it back in to find out what this is, or remember, you can just use your table. So I highly recommend plugging it into your graphing calculator and using your table there to construct the points. Okay? And again, you don't have to write down all my work. Okay? I'll post this, and then this would be a good thing for you to try if you got something wrong. Now, because this opens downward, all of the points are below it. So anytime you're doing the range for something that opens downward, its y is less than or equal to the y-coordinate of the vertex. But if it opens upward, all the points are above, so that's why this one is y is greater than or equal to the y-coordinate of the vertex. And for the range, it's all about the y-coordinate, because remember, the range is the possible y values. Okay? All right, let's look at our graphs. So for number 9, I have my vertex here, 1.5, 3.25. Okay, and then to find your other points, again, you can go to your table. Oh, with your 1.5, when you're doing your table, let's do that one together, because you have the decimals. So let's do y equals, and then you have to do negative x squared plus 3x plus 1. You can also create your own table. When you guys did your own table for that, what values did you use, or how did you pick the values? Or were we confused on that part? Because it was a decimal. If it's a decimal, just go to the next whole number, okay? So for this one, if I go to my table, okay, if I know that this is 1.5, I'm just going to use 0, 1, and 2. Or really 0, 1, and then 2 and 3, and then I'm going to plot those points. Now, if you want to see what the vertex is, because it's 1.5, I'll show you a quick trick, okay? See how this one says table set here? You can go to second, this window, and you can have your table start at 1.5. Okay, and then instead of it going by ones, you might want to go by halves. But you could do that to find your other coordinate, and then you could go by halves here to see all of the other ones. If you're like, oh, I'm not going to remember how to change that back, let's go change it back now. So second table set, you could start at 1.5. You could go by ones, but then if you go here, see how it's going to be 1.5, 2.5? So if you don't want to deal with that, you can just start at 0, right? So you can pick any of those points, and then you can always find your vertex by plugging it in. Okay, so you can plug in 1.5 to your function and then calculate. All right, and then that's number 9. Do you guys have questions for me about number 9 with the decimals? Mm-hmm.
So for the test, are
Yeah.
you gonna want us to change the mixed numbers and the fractions and stuff from the vertex to a decimal for the range, or can I just say that?
Oh, no, it can absolutely stay as y is less or equal to 13 over 4. Yes, either one. Good question. So, yeah, so you can, this one here, I just put it as the decimal, but you guys can use the 13 over 4. Good. Other questions on that one? Yeah. Julia? This is more intense than what the test is going to look like. So, like, the first question is going to be something like 1, 2, or 3. See how those are all the same type? Yeah. So you're not necessarily, you're not going to have like 3 of those and then 3 of these and 2 of these. It'll be like 1 of these, 1 of this type, 1 of this type. So it won't be as long as that. All right, and then what about number 10? Number 10 doesn't have a decimal in it, so when you do the y equals, you won't have to worry about all that extra stuff I just told you. You can just do 2x squared plus 4x minus 2. You can go to the table, and then your vertex, if you know negative 1's in the middle, right? Negative 1, negative 4. And then you can see how the other points around it are going to be symmetric. And then that's what you're going to plot on your graph. Okay. And on your quiz, you won't have to plot multiple ones on the graph. I don't like that too much, but that's how this one was set up. All right, let's go to the back page.